Hi, I'm Dr. Oliver. So today I'm going to discuss about the introduction about automation and control system. The first part of automation and control system laboratory. We'll see some introduction about automation, especially fluid power automation in hydraulics and pneumatics. In detail, we are going to discuss about how we can draw a circuit. So before discussing about the circuits, we are going to discuss about the components, symbols, why we are choosing fluid power automation, why we need pneumatics, why we need hydraulics, how it is far ahead than mechanical transmission and electrical transmission, what purpose we are giving more importance to fluid power automation. So these are all things we are going to discuss in this part. So these are all the contents we are going to discuss. So we are going to discuss this motivation to use a fluid power system. That means why we need in industries. Then we are going to discuss about the types of fluid power system, its advantages, disadvantages, applications. Then we are going to discuss about the basic principle of pneumatics or the fluid power system. Then basic components of pneumatic system. And then second part we are going to discuss about basic components of hydraulic system. Okay, we'll start one by one. So what is the need of an industry? So in general, what is the need of an industry? So we can see in industries always they need precise machining, they need automatic systems. So we can see CNC machines, servo valves, and so many advanced machineries we are seeing in industries. They all need a good transmission system as well as precise system. So if you are comparing with the steel plant, you can see high and precise rolling force, varying rolling force. They are having sheet rolling with varying torque. If you are going for a hydraulic press, you can see the punching force, potential energy regenerations. Then you can see if you are taking a heavy machinery industries, you can see their power generation is heavy, higher range of power generation they need. Loads also fluctuating. Then we are seeing aerospace industries, aeronautical and defense industries, we can see different actuation points, precise actuation, and lightweight component design. These are all some of the industries. Then when we are applying some industry, for example, mining industries, applied industries, mining industries, automotive assembly industry. So these all can lead in an industry. So you can see in an industry, if we need all this. In manufacturing industries, we need precise systems. Steel plants, the force are different, torque is different. They need different force for rolling as well as not only the different force, they need high and precise rolling force. An hydraulic press, so they need high punching press as well as potential regeneration. So this all needs. So how we can uh, fulfill this need with the help of this fluid process. Okay. So in our industries we can see the power transmissions are mainly because of mechanical, electrical, and fluid power. So when you see mechanical electric transmission, you can see chains, pulleys, gears, cams we are using to transmit the power. Electrical transmission, which are using wire to transmit electric current for a long distance. The third one is fluid power transmission. So it is a fluid power. What is mean fluid power? So fluid power transmission. So we know mechanical transmission. So all nowadays we are in use. It's a old technology. It's a long-term, long life technology we are using for a long time. Then electrical transmissions also we are using more usage in industries. So another one term we are calling fluid power transmission. So what is mean fluid power? It is the use of confined fluid flowing under a pressure to transmit power from one location to. So we are using a fluid which is used to pressurize and to transmit the power from one location to. So it has the ability to multiply the force, flexibility in change in direction without any damage to it. That is the advantage of fluid power system combined with the mechanical. So if you have, for example, mechanical power transmission, it gets wear and tear. If you are going to stop immediately means it get crashed, it get collapsed. We can't change the directions. You can see the train. If you want to stop immediately means it get collapsed. Similarly in electrical power transmission, so power cost, high power cost unit. So compared with the mechanical and electrical fluid power transmissions, we have the ability of multiply the force. So we can multiply the force. For example, we have a 100 centimeter long stroke arrive means after 50 centimeter we can multiply. That means we can have the flexibility to increase the force. So we can multiply the force after 50 centimeter. So while doing the punching stroke, we can increase the force. So that flexibility we are having in our fluid power transmission. Also easy to change the direction. So why we need this fluid power system in our industries? Because it helps to eliminate all the complicated system using gears, cams, or mechanical transmission. It eliminates the need of the complicated system. We can easily transmit without any slack or without any loss in the solid mixing power. Usually, they can have a small slack in our mechanical systems. So small, precise system we can't reach in mechanical. Then the fluids are not subject to breakage as for mechanical parts. So here wear and tear will be more in mechanical, but in fluid power system there is no wear and tear, no breakages, no contact surface. So it is fluid power system mechanism are not subjected to great wear. So whether it is developed nowadays, when we see about its history, we can see it's a history of 5,000 years ago. But in between, it's not flourished. By 9615 or 1615, Pascal discovered the fundamental law of physics. You know, all hear about the Pascal's law. Based on that law, by 1795, Joseph Bramah built a hydraulic press. Then slowly, due to the Industrial Revolution in 1850, they used water press or other industrial machines. Then in 20th century, the modern fluid power era used in the place of the electrical system. So initially mechanical, electrical in industry. Now it was replaced by the fluid power system. In 1926, self-contained package, self-contained package system was developed. Okay. So self-contained package system was developed in 1926. Okay. So what is the fluid power? Always we are calling this a fluid power. Fluid power. What it means? So it's a technology that deals with the generation, control, and transmission of force to do you some useful. So for doing the useful work, we are having a mechanical element. It takes up pressurized fluid in a confined system. So it's a technology that deals with the generation, control, and transmission of forces and movement of mechanical element with the use of pressurized fluids in a confined system. So it generates a, we are generating the force, we are controlling the force or direction control or flow control. Then we are transmitting the force to do some useful work. So it means convert, transmit, control, and apply the fluid energy to perform the. So here we are having two terms of fluid. One is hydraulics, and one is. So if you use oil, water, or liquid form we are using means it is under pressure. Liquids under pressure means it is for hydraulics, and pneumatics means you use compressed air or any neutral gases you use to run the system means we can call as pneumatic system. Okay, so there are two types of fluid for hydraulics and so you can see. So hydraulics means it's the science and technology of mechanical properties in liquids. Science and technology of mechanical gases means called as pneumatics. In Greek, it's called as hydro. Hydro means water. Pneumo means it's a wind or breath. Okay. And further, we can classify these fluids into fluid statics and fluid dynamics. So what we are discussing in fluid mechanics, that is under static, under rest. So when we are under rest, we are calling as fluid statics. Under motion, we call as a fluid dynamics or fluids in motion. So, for example, you want to measure the quantity of flow, measure the velocity of flow, or we want to know the amount of flow. So that we can measure with the use of analysis equation or picture tube or venturimeter or fish meter. So the flow rate also we can. But when we are going to make use of this fluid to do some work, we call it hydraulics and pneumatics. Okay. So next, what is meant by pneumatics? Already termed as pneuma is the breath. So pneuma means breath or wind. It's a Greek word. It's a name given to the branch of physics. It treats the properties, motions, and behavior of the. So it's a pneumatics, a branch of science called physics, which treats the properties, motions, and behavior of air. Or it's a section of technology that deals with the study and application of pressurized gas to produce mechanical motion. It's a section of technology that deals with the study and application of pressurized gas to produce mechanical motion. Okay. So why we are choosing pneumatics? What purpose? Whether any benefits you're having, but to choose this pneumatics. Yes, high speed, inexpensive and mature technology. Also, it is easily available, low on cost, freely available. You can see air, it's a freely, plenty of air is available, so you can get to the low on cost, reliability, long service life, storage also very easy. You can see in roadsides workshops, you can see the compressor, it was stored anytime we want, we can use. So when you want it transportable, it's no loss of power during storage. Also, it's for safety, it's hazardous or sensitive or clean room. For example, in coal mines, you can use petroleum refining, LPG bottling, and medicine industries, pharmaceutical industries, everywhere we can use this. Okay. So, what is hydraulics? So, pneumatics, we are saying. So, pneumatics means it's a breathe or pneuma, it's a breathe. Likewise, in hydraulics, we can term as hydro and allos. So, hydro means water, allos means pipe. So, water in a pipe, we call as hydraulics. So, it's broadly classified into two categories, hydrostatics and hydrodynamics. So what we are dealing is hydrostatics. So hydrostatics is the study of confined fluid, transmitting power, modifying motion, and multiplying forces is called hydrostatics. So study of the confined fluid, transmitting power, modifying motion, multiplying forces is called hydrostatics. So a good example is hydraulic press. So 1 ton press, 2 ton press. In all industries, you can see hydraulic press is that comes under hydrostatics. The second one is hydrodynamics. Systems in which the kinetic energy of the moving fluid is used are called hydrodynamic systems. For example, in all our houses, in industries, you can see the centrifugal pumps are reciprocating or non-positive displacement pumps we are having. It's called pumping systems we are using. So, a centrifugal pump with a pipeline comes under hydrodynamics. Okay, these are the different categories in hydraulics. Why we choose them? So, in pneumatics, because of it low cost, easily available, very fast approach, so we are choosing pneumatics. So why we prefer hydraulics in some other place? Because high range of power generation. So heavy machineries already in the first slide we are discussing in the beginning we are discussing about the what is the need of the industries. So today's need of industries high precise and heavy machineries are used. So high range of power they need. Also fluctuate in operations doing changes in characteristics in mechanical and electrical. Okay. So also they need smooth power transmission. So that are all we have received in hydraulics. That's why we choose hydraulics. So these are the difference between pneumatics and hydraulics. For example, when you see the pneumatics, higher speed, especially 1.5 to 3 meters per second. At the same time, Hydraulics only 0.5 meter per second. Force available up to 50,000 Newton. Here it is 5 crore Newton. So high power you want means high force you want means you can go for hydraulic system. So high temperature areas up to 200 degrees centigrade we can make use of pneumatics, but in hydraulics it's not possible. It's not suitable for temperature beyond 100 degrees centigrade. Cylinder force is proportional to amount of air entering the cylinder. It's highly controllable. The cylinder travel is proportional to amount of oil entering the cylinder, hence highly. So both are well suited for delicate handling jobs, not suited for delicate handling jobs. Cylinder position is not predictable under dynamic loads, but in a hydraulic system, it is a predictable all kinds of loads. Therefore, very smooth. Here you can't expect that smooth movement in pneumatic system. When you're positioning the pneumatic cylinder, it can be done with a moderate level of accuracy, usually 1 to 2 mm. The changes will be there, but the positioning of hydraulic cylinders are so accurate, much better than the pneumatic system. But accuracy will be there, usually better than 0.25 mm variations. So it's a precise precision is 0.25 mm variation. So not well suited for handling high starting load, very well suited for high starting loads. Okay, these are all the differences between the pneumatics and hydraulics. When you're comparing the pneumatics and hydraulics, so when you need a high speed system with low force means you can go for pneumatics. At low cost means you can go for pneumatics. But in high force, high precise system, slow speed, then we can move it to hydraulic system. What are the advantages of pneumatics? So it is required less than 50,000 Newton. So you can prefer pneumatic over hydraulic. If you want to move the range of 2 mm to 3 mm with the special readiness, even 10 meter also possible. Maximum 1.5 meter per second is faster than the hydraulic system, it's 0.5 meter per second. And the velocity up to 7 meter per second is also possible. Air exists freely in atmosphere, no problem by depleting the resources. So no need to bother about if oil we are using, for example, we are using crude oil or petrol or diesels, we are seeing the resources we have to protect. So here we are not going to deplete the resources. Freely in atmosphere, no problem like depleting the resource. Also, it can be transported a long distance, 1,000 meter you can transport, but we can't take oil more than 100 meter. The temperature also, change in temperature does not affect the steady state performance of the system. Cleaning also very easy, leakages of pipe does not contaminate. So it will be used in food industries, pharmaceutical industries, chemical industries, textile industries, printing industries, or any industries. Assembly line in automobiles, you can go for pneumatic system. It will not burn in our working. So maximum working pressure is 6 bar to 8 bar. So it is very safe, also explosion. Initial cost is high to install this setup, but maintenance cost is low, so it is so economical. Okay, these are all the advantages of pneumatic system. At the same time, we have some enormous advantages. We have some disadvantages also, limitations also. So beyond the 50,000 Newton, we can't go for pneumatic. It's not commercially good, so we can go for hydraulic over pneumatic. When cylinder moves, stick slip motion. So we can see when you want to start after rest. So stick slip motion will be there. Displacement is not smooth. So jerky noise also will be there. So air has to free from dust. So always you have to protect the system. So you have to keep air free from dust, humidity and moisture. Otherwise it will corrode the system, spoil the sealing elements. So air preparation is very much important. Then when you exhaust the air, it creates noise. These are all the applications in areas of automobile industries, petroleum industry, petrochemicals, food industries, packaging industries, then machining, robot, there is pneumatics, then electronics also, we can place assembly line of the electronic, especially that substrates, handling the substrate we are using pneumatic system. Okay. So let us see now some examples. So where we are using pneumatics. So pneumatics are used to dismantle the air. So now in all industries, all local areas also you can see this kind of workshops or machinery machine shops we are having this system, pneumatic machine to dismantle the automobile tire. When you want to demolish the building, you can go for a heavy duty pneumatic jack hammer. Then painting and pneumatic is used to automobile painting also in assembly line you can see this. Then another one is you can see the pneumatic filling machine. Automatically it fills the machine. Then in dental industry, dentist use dental one of the use of pneumatic technology. Also we can see the fill the tire with the air. Compressor to adjust the tire pressure. We can see in all petrol bunks or in workshops. So these are all some of the examples, some of the applications where we can see pneumatic systems. Okay. So hydraulic press, you can see automobile application, motion control of planes, civil engineering applications, aviation machinery, industrial robotic, economic machinery. These are all hydraulics applications. So you can see bulldozers, or these bulldozers or these recipes are hydraulic operated systems, heavy duty machineries. Okay. These applications are hydraulic system, hydraulic trucks, cranes, press, so all are agriculture equipments, all are hydraulic operated system. Okay. So these are all the applications in hydraulics and pneumatics. Okay. So this is an hydraulic brake. Okay, hydraulic brakes. We are having hydraulic power steerings also used. So power brake we use it hydraulic system. Okay. Okay. So now we have the introduction. We know about the types, what is the difference, the benefits of hydraulics and pneumatic system. Some applications where it will be used, that also we discussed so far. Now we see how it works. So in the beginning itself, we are discussing about the pneumatics and hydraulics, the history of pneumatics and hydraulics. We can see it, in 1630 it was developed by a law by Pascal's created a law. Based on that law only we are going to use or we are going to operate this pneumatic and hydraulic. So Pascal's law, pressure applied to a confined fluid at rest, it acts equally in all directions and right angles to any surface on which it acts. So for example, you can see here 20 square inch of area of a closed vessel which is having is full of oil or a container which consists full of fluid or any liquid. It's not a compressible liquid, it's a non-compressible liquid. When you're applying a small force, for example 10 lbs you're applying means this force, what will happen means it will expand in all the areas. So all areas it was applied. So at the bottom of the container was 20 square. Total the result of force will be 10 psi times 20 square. So we are getting output of 200 pounds total force since each force equals pressure in times. So 1 square inch we are applying a 10 lbs, 10 pounds 1 square inch. We are applying a 10-pound force and we are getting output of 200 pounds. We are with in a confined area, it acts equally in all directions. It acts equally in, so based on the size, it gets varied. Okay, we'll see one example. So for example, we are having a forklift or hydraulic lifts. A small cylinder is connected to a big cylinder. So small cylinder we can see in automobile shops. A small force we are applying, the force F1 we are applying. This force You can see a small force we are applying. The force is F1. We are having F1. Its area is A1. Its area is A1. A small cylinder. Now it is connected, interconnected to a big cylinder. What's the size of the cylinder? Area is its area is A2, and its force is F2. Okay. So you can see here small amount of force we are applying according to Pascal's law. When it comes to a big cylinder, this force equally transmit in all directions. So we are getting a force of F2. So pressure equal to force by area. So F2 equal to this much of force I am getting F1 into A2 divided by A1. So that much of force everything. So we are easy to lift a vehicle or anything we can lift. Okay. Anything we can lift. So these are all this we can see uh, how Pascal's law is implemented in our system, how it helps, how the physics works in our system. Okay, so it's Joseph Brahma's principle. It was developed in 1830. The next we can see the basic components of hydraulic system. Basic components of hydraulic system. So we are having six basic components. One is pump, then we are having valves, actuator, then we are having a prime mover, then reservoir, then interconnect all these we are having those. These are the six basic components of hydraulic system. So a number of types here you see one by one. Then other things also we are having. You want to run a system means practical applications. We need some filters, heat exchangers, accumulators, then other components also we are having. So these are all the basic components of hydraulic system. Okay. So you can see the basic component. It's a tank, fluid reservoir with having a filter, then a hydraulic pump. This pump is run by an electric motor. Then we are having a pressure regulator to control the pressure. Then we have a control valve to control the flow, to control the direction. Then we are having a cylinder, so horizontal rotary or cylinders we are having. So we are having a cylinder with a piston. Okay, these are all the, or we call as actuator. We call as an actuator. So these are all the basic components of the hydraulic system. Okay. It's one of the hydraulic typical system, how it will be. So we can see the pump. Here we are having a pump. It's a uh, gear pump. We have a oil tank. So from oil tank, this is oil tank. From oil tank, we are pumping oil, and it is diverted to the flow control valve, then to the direction control valve. So in between this, we are having a pressure relief valve. In between this, we are having a pressure relief valve. It will monitor the system pressure. If anything happens, it will divert the flow to the reservoir. Okay. So then a direction control valve is connected to a hydraulic cylinder, where we are having a throttling valve also. If you want to divert the fluid means you can have it without that DCV, you can divert it. For that purpose, you can have it throttling. No, you can control the flow by using the throttling valve. Okay, control the flow by using the throttling. So these are all the components hydraulic system. We use in hydraulic system. We use hydraulic fluid. It's the lifeblood of the system. When we choose this hydraulic fluid, the following functions we have to maintain. For example, we need to transfer properly. So fluid power efficiently, transfer fluid power efficiently. Then we have to, there is no separate lubrication they are using. We have to lubricate the moving parts, then absorb and transfer the heat generated within the system. So it's a high power system, high pressure system. So we have to absorb the heat as well as we have to dissipate the heat for that purpose also. So be compatible with the hydraulic components. Mechanically it should be compatible, then remain stable lines, wind range of possible physical and chemical changes. So these are all the functions we need while we choose the hydraulic fluid. So easy to transfer. Transfer fluid properly or efficiently, lubricate the moving parts, absorb and transfer the heat generated within the system, be compatible with hydraulic components, remain stable against wide range of possible chemical, physical and chemical changes. Okay. So different types of fluids they are using. So some of the fluids are petroleum based, this is fire resistant, water based. So nowadays we are having fluids with mineral oil, water, phosphate ester, water based, ethylene glycol compounds, and silicone fluid. Now advanced some new fluids are also to reduce the expenses in fluid. So we'll choose a fluid. We have to maintain all these properties. So it's compulsory to check the properties of the fluid what we are going to use in a hydraulic system, especially viscosity. We have to know the viscosity of the system. So ideal viscosity, then lubrication capability, then de-emulsibility. Moisture content have to be zero. Stability with the environment as well as chemical, incompressibility, fire resistance, low flammability, foam resistance, low volatility, good heat dissipation, low density system compatibility. So these are all. So when you choose a hydraulic fluid, first of all we have to check the properties of the particular fluid. So viscosity index is very important. Viscosity level is very important. Then it should be good lubricant. It should be de-emulsibility, water content we have to remove. It should be incompressible fluid, fire resistant. Because we are going to use it 100 degrees centigrade or 200 degrees centigrade. Then we have to check the fire resistance. Density should be low, foam resistance, good heat dissipation, low flammability, system compatibility. So enormous properties we have. Okay. So first it's six basic components. One by one we'll see some just a small introduction about these pumps. So what is a pump? It's a device that moves fluid. It's a liquid or gas or sometimes slurries by mechanical action. It's a mechanical device that converts mechanical power into hydraulic energy. As a moving pump part, for example, it may be a moving part, maybe a gear, or impeller, or vane, or piston, or diaphragm. It begins to move, air is pushed out of the way. When you start with external power, the gear rotates. So what will happen means when it is rotating, in the meshing area, it gets volume reduced, pressure increases. When you have demeshing area, volume increases, pressure decreases because less than the atmospheric pressure. Because of that, only section occurs. So the movement of air creates a partial vacuum, which can be filled by more air, or in the case of water, maybe water. There is a principle it works. An hydraulic pump operates perform two functions. One, it creates a vacuum. So demeshing and meshing, for example. It creates vacuum at the pump level, so volume gets increased, which allows the atmospheric pressure to drop and the reservoir pressure. So it pumps the oil or liquid from the reservoir. Second, its mechanical action delivers this liquid to the pump outlet and forces it to the hydraulic system. Okay. What are different types of pumps? So initially we can classify into non-positive displacement pump and positive displacement pump. So non-positive means the volume of liquid delivered for each cycle depends upon the resistance output to flow. So there is no such deliver. So volume of deliver for each cycle depends upon the resistance output to flow. So if you stop with flow, it won't create any. So no need to have outlet whatever we are getting as input. Second one is positive displacement. A definite volume of liquid is delivered for each cycle of pump, regardless of resistance, as long as the capacity of the power unit driving a pump is not exceeded. So whenever a definite volume of input will be there, that has to be without any resistance, it has to go out. Okay. If the capacity of the power unit driving a pump is not exceeded, so if any issues happen, it gets collapsed. So different types of positive displacement gear pumps. We are having internal gear pump, external gear pump, low pump, zero pump, and screw pump. Similarly, vane pump we are having fixed vane pump and variable displacement pump. Then piston pumps we are having radial and axial. Axial we are having bend axis and thrust plate. So you can see this chair for external gear pump, different types of pumps. External gear pump. So when the gear rotates, you can see here when when the gear rotates, so what will happen here when readiness occurs, volume increases. So vacuum, small vacuum is created. So it drops the pressure beyond the atmospheric pressure. So suction. So because of continuous running, it carries the fluid to the meshing area. So when it is meshing, the volume decreases, pressure get increases, so it exits the fluid. So likewise, internal gear pump, here we are having crescent shape element is there. Because of that, number of gears also less. Two different gears are meshed each other. Cannot mesh one by one. Okay. So here it is meshed it. So low pump is one form of external gear. More volume you want to transfer, you can go for low pump. And vane pump also there. Different stuff gears we use the vanes. So it's a vane pump. Different types of vane pumps are having for fixed displacement pump and variable displacement pump. Okay. The next one is actuator. Next important component is actuator. So it's a cylinder called a linear hydraulic actuator. Similarly, you're having rotary. It's a mechanical actuator that is used to give a unidirectional force to a unidirectional stroke. Okay. So different types of actuators you're having: linear actuator, rotary actuator, and semi-rotary actuator. So hydraulic cylinders are called as linear actuator, and hydraulic motors we call as rotary actuators. Okay. Different types of cylinders here: single acting, double acting, telescopic cylinders, tandem cylinders, special types. Tandem cylinder, double rod cylinders also there are. Okay. Here you can see the symbolic approximation of a single acting cylinder. Single acting cylinder. Okay. So single acting cylinder with this spring weight on. Okay. Here in this picture we are seeing the telescopic cylinder. So in all our tracks you can see this type of strokes. Whenever we need a long stroke, we can go for telescopic cylinder. So especially in all our lorries or trucks, we can have this kind of long stroke to dump the soil or bricks or metals. So how it is working means it is having a number of cylinders. Each cylinder acts as a piston as well as. For example, the first phase it acts as a cylinder and next cylinder acts as a piston. Then second phase, third cylinder acts as a piston. Third phase, fourth cylinder acts as a piston. So we will get a different stages. 3 stages, 4 stages, 5 stages we are having. If you want to extend the position of this cylinder or long stroke units, you can go for telescoping. So one type of cylinder. The next valves we are having, hydraulic valves. We have different types of valves we are having. Direction control valve, pressure control valve, and flow control valves we are having. So direction control valve, we are having type of direction view, we can see that one. And pressure control valves, in hydraulic systems, we are using relief valve, reducing valve, pressure reducing, sequence valves, counterbalance valve, and unloading valves. Flow control valves also we are having non-pressure compensator, flow control valves also. Okay, you can see the different types of direction control valve. Based on its construction, we can classify into puppet valve and spool valve. Based on the port, we can classify into two-way valves, three-way valves, and four-way valves. Number of its position we can call as 2 position, 3 position. Then actuating mechanism we call as mechanical actuation, manual actuation, solenoid actuation, hydraulic actuation, pneumatic actuation, indirect actuation. So these are different types of direction of the valve. Okay. Now we see the hydraulic cylinder, how it is. Okay. See, when the motor runs, immediately it runs the pump. Now it is suction occurs. So when we are carrying the fluid to the direction, for example, what type of direction of the valve? It is a lever operated 4 by 3 DCV. 4 by 3 DCV. In between, for all the hydraulic system, we need a pressure relief valve. We need a pressure relief valve. So now it is, when we are applying the force, it is moving. So what will happen? It moves the piston out. So it is carrying the weight. Okay. So when the pressure increases, setting cracking pressure increases, immediately it gets open and direct the fluid to the reservoir. Okay. These are all symbolically represented how the fluid moves from blanket to rodent. So rodent to whatever we need we can have. For example, so now it is in center position or center closed position. This is center closed position. Okay. Now we can see it's moving. So now we are applying force the rod in sorry in the blanket because of that it moves the piston up. Okay. So what will happen? The oil inside the cylinder it drains towards this direction and towards the cylinder. Okay. So you can control. So we want to return back means we are diverting the fluid to the next position. So to the rod end, so it drops. Okay. Okay. The next one is basic components of pneumatic system. Basic components of pneumatic system. This one we will continue in the next video. We will see the basic components of pneumatic system. So we'll see in detail about the pneumatic system in the next video. Okay. So far we discussed about the need in the industry, what are the transmission systems we are having in the industry, whether it is why we prefer this fluid flow system, what are the different types of fluid flow system, why we need pneumatics, why pneumatics better than hydraulics, why hydraulics is better than pneumatics, where it will be used, so many applications also we have seen. So in this, we're going to end up the first part of the introduction. The next part we will see the basic components of pneumatic system. Okay, we'll go across these basic components of pneumatic system. Okay. Thank you. Thank you for your patient listening this video. Thank you. Thank you.